everyone! Welcome to this video 8.1, Solving Equations by Multiplying or Dividing. In this video, we're going to use the method of isolating the variable in order to solve these problems. I hope you remember from the last video what the word isolate means. The word isolate means that you're getting something alone. You're getting it by itself. In the problems that we do today, you're going to see things like 2x equals 10, and we're going to try to solve and figure out what x is equal to. To do that, in order to isolate the variable, we need to get rid of anything that's by the variable so that we can isolate it, get it by itself. So we're going to learn a method today of how to get rid of numbers like 2, not just by crossing them out, but actually doing something mathematically that will allow us to solve the equation for x by getting rid of anything that is on the same side of the equal sign as the x. Let's take a look at the first example problem. In this problem here, we have 2x is equal to 12. This problem is represented here on our scale by there being two x's, and that's equivalent to 12. So you can see this number 12 here is represented just by 12 squares. And then the two x's are being represented by, we don't really know exactly what number it is right now, but just kind of two rectangles of length x. When we solve this problem here, we need to isolate the variable and make it so that there's only one x. So we need to somehow get rid of this x. But I can't just cross it out because then I would have to also cross out an x on this side, and I don't have an x on that side. So crossing it out is not going to be the way that we solve this problem. What's another way that we can isolate the variable and make there only be one x on the left side? Well, I'm noticing that there are two x's here, and I'm noticing that I could make this into two different groups. I could make this one group, and I could make this another group. If I separated all of those numbers on the right so that they were both a part of two different equal groups, couldn't I say that one of the x's is equal to one group, and another x is equal to another group? I could say that. What I've just done is I've divided all of the numbers on the right side up into two different groups because there were two x's here. And so I found that one of the x's was equal to 6, and the other x was also equal to 6. So the answer is one of the x's is equal to 6. Two of the x's that we started with, two of the x's were equal to 12, but one of the x's is equal to 6. That's how to solve the problem using this scale. Let's see if we can solve the problem algebraically. To solve the problem algebraically, I would start with 2x equals 12. Then, to isolate the variable, I need to figure out a way to get rid of this 2 right here. Here's a hint. First, identify which operation is happening on this side of the equal sign that has the variable in it. The operation could be addition, subtraction, multiplication, or division. In this problem, when I have 2x, the operation that's happening is multiplication. The 2 is being multiplied to the x. So what I need to do here is I need to do the opposite of multiplication in order to get rid of the 2. The opposite of multiplication would be division. So algebraically, I'm going to divide both sides of the equation by 2. When I do that, on the right side I get 6 because 12 divided by 2 equals 6. And what happens on the left side? What is 2x over 2 equal to? Well, remember, if you have a fraction like 4 over 4, that fraction is equal to 1. If you have a fraction like 2 over 2, that's equal to 1. So over here I have 2x over 2. Both of these 2's can end up canceling out because it's going to equal 1. So what I'm left with is just x. So my final answer will say x is equal to 6. Let's take a look at a word problem for this exact same problem here, 2x equals 12. Here's what a word problem might look like. I have 2 bags of jelly beans. Altogether, I have 12 total jelly beans. How many are in each bag? To do that, we're going to split our number in half. We're going to say this bag has X number of jelly beans, and this bag has X number of jelly beans. We know that altogether there are 12, so I'm going to count 1, 2, 3, 4, 5, 6. There are 6 jelly beans in this bag, and there are also 6 jelly beans in this bag. So one bag, or 1x, is equal to 6 jelly beans. That's what a word problem might look like for this type of problem here. Let's do just 2 more examples similar to this. In this first example, I have 5y is equal to 15. We're going to solve this problem the algebraic method. Remember, to do that, first I have to identify which operation is happening here in my problem. I notice I have 5y, that means multiplication. The 5 is being multiplied to the y. In order to isolate the variable, I have to do the opposite operation. So since the 5 is being multiplied to the y, I have to divide both sides by 5, and then the 5's will cancel over here, and I get y is equal to, let's see, 15 divided by 5, 3. Y is equal to 3. It's very, very, very important that you practice using this method. Do not try to use substitution because you're going to need to know this method in this chapter. We are going to solve problems that get a little bit more complex. You've got to start practicing using this isolating the variable method. All right, here's the next problem. 24 is equal to 3x. I'm also going to ask myself which operation is happening here. Well, 3x, that means 3 is being multiplied to the x, so I have to do the opposite thing, so I have to divide both sides by the 3. When I divide both sides by the 3, that will get rid of the 3 on this side. They will cancel, so I will just have an x on this side, which is exactly what I want, because I want to isolate the variable. And then 24 divided by 3, that equals 8. So x is equal to 8. All right, we've done some problems with multiplication. Now we're going to look at problems that are going to look just a little different. Let's take a look at this problem here. Y divided by 3 is equal to 4. If you take a look at this scale here, it's showing that if we had this entire bar would be worth y. But we don't even have one whole y. We only start with a third of a y. We only have part of a group of a y. We know that a third of a y is equal to 4. We want to know what one whole y would be equal to. To do that, in my picture here, I'm going to need to add a little bit more to both sides of my balance scale. I'm going to have to add another one of these boxes, which is equal to the same thing that the first box was. Wasn't the first box equal to 4 wholes? So this next one that I'm drawing should be equal to 4 wholes. And then right now I have 2/3 y. I need there to be 3/3 y so I can have 1 whole y. So I'm going to add another 4 wholes to this side. Now I have 1 whole y over here on the left, and on the right I have 12. So 1 whole y is equal to 12. If we were going to solve this problem, the algebraic method, I would start by looking at my problem and I would ask myself, which operation is happening here? My y is being divided by 3. I need to undo that operation by doing the opposite thing. The opposite of division is multiplication. So I'm going to multiply both sides by 3. On the right, 4 times 3 equals 12. What happens on the left when I have y over 3 times 3? Well, I can turn this whole number 3 into a fraction, make it 3 over 1. And when I multiply it, I'm going to do top times top and bottom times bottom. So I get 3y over 3. And these 3's will cancel out. So I'm just left with 1 whole y. So y is equal to 12. Let's take a look at a word problem for this problem here. This is what a word problem might look like. If a third of a pizza, where did I get the third from? Yeah, the y divided by 3, that's a third. So if a third of a pizza had 4 slices, how many slices would there be in the whole pizza? So this problem is showing that 1/3, or y over 3, 1/3 of a pizza is equal to 4. 1/3 of a pizza has 4 slices. The question is, when we're isolating the variable, we are solving it for y. We want it to be 1 whole y, 1 whole pizza equals how many slices? Well, if there are 4 slices in that third, then there would be 4 slices in this third, and there would be 4 slices in this third. So altogether, there would be 12 total slices. That's what a word problem might look like. Let's do a couple more example problems, kind of like this. This first one says, x divided by 2 is equal to 20. This means that half of a group of x is equal to 20. If I were to draw a bar model for this problem, this bar would represent 1 whole x. And I know that half of the x is equal to 20. The question is, what is 1 whole x equal to? Well, if half of the x is 20, I know that the other half is also 20, so the entire x is equal to 40. And if I'm trying to solve this problem algebraically, I'm going to do the opposite operation here. If x is being divided by 2 in this problem, I'm going to multiply my problem by 2 on both sides. And when I multiply my problem by 2 on the left, the 2's will end up canceling out. So I just get x. And when I multiply by 2 on the right, 20 times 2 is 40, which is my answer. And the next problem says y divided by 3 is equal to 6. If I have my bar model for this problem, this entire bar is equal to y, and I know that 1/3 of the y is equal to 6. So the question is, what is 1 whole y equal to? Well, I'm going to have 1/3, another third, another third, so 1 whole y is going to equal 18. If I do this problem algebraically, I'm going to do the opposite operation here. Because this is being divided, I'm going to multiply both sides by 3. These 3's are going to cancel, so I get y equals, and then 6 times 3 gives me 18. All right, we did a lot of problems together. Now you guys have an opportunity to try some on your own. Go ahead and pause the video, and you can try these 5 problems, and then after you try them, you can come back and check your answers. All right, here are the answers for these problems. Now remember, it's important that you know how to solve these problems using the isolating the variable method, not just using substitution. So let's talk about number 2, 3, 4, and 5 and how you can do that using the isolating the variable method. For number 2, when you isolate the variable a, you ask yourself, which operation is happening here in the problem? I notice that it's 6a, which means 6 times a, so I have to do the opposite, meaning I have to divide. So I'm going to divide both sides by 6. When I divide the left by 6, they cancel out, and I get a equals, and when I divide the right by 6, I get 7. a equals 7. For number 3, we have 65 equals 13b. Again, I notice 13b means multiplication, so I can divide both sides by 13, and 65 divided by 13 is 5. So 5 is equal to B. For number 4, we have m divided by 8 equals 9. Since division is happening here and we have to do the opposite, we're going to multiply both sides by 8. The 8s will cancel over here, and we will get m equals 72. And for number 5, we have 12 is equal to n divided by 7. I notice that division is happening here, so I have to multiply both sides by 7. 7 times 12 is 84, so 84 is equal to n. All right, that's it for the official video. Go ahead, take a picture of your notes, submit those notes on Canvas. I do have a few more practice problems for you guys to do, just to help you get a little bit more practice with this section. These practice problems are on page 65, and we actually already did the addition and subtraction problems earlier, so the only ones we have left to do right now are the multiplication and division problems. After you have taken a picture of your notes, after you have submitted those to Canvas, go ahead and come back here, take a look at these problems, and as you're working on them, Miss Mercer has the answers, and she can check your answers on Microsoft Teams, and she can help you with any problems that you need help with. Just ask her your questions on Microsoft Teams. Thanks, guys. Have a good rest of your day. Bye.